Welcome to part 2 of the All About the Periodic Table video series. We're going to discuss the atomic number. Okay, at this point, hopefully all of you know that an atom is made up of protons, neutrons, and electrons. And the atomic number is specific for each element. So if an element has an atomic number of 11, like here for sodium, there's no other element besides sodium with the atomic number of 11. If it has an atomic number of 12, then it is a different element. The atomic number is equal to the number of protons in an atom. So this is its identity. This is an element's identity. And it's equal to the number of protons. And you will see this number appear above the symbol of an element in the periodic table. Okay, so if we go back and look at the periodic table, you can see these numbers above the symbols are the atomic numbers, and they represent the number of protons in the element, or in the atom. Okay, so if we were to pick any element on here, so let's pick bromine. All right, so if we go find bromine, as you get more familiar with the periodic table, the easier this will be. Okay, it has the symbol of Br, so here it is here, and it has a number above it of 35. This is the atomic number. This means that bromine has 35 protons in its nucleus. Okay, so now we know that we can determine the number of protons in the nucleus. Okay, and we also know that electrons they're actually in orbitals, but they surround the nucleus. And also in our nucleus, we have neutrons. Okay, and so we need to not only know how many protons we have, but we need to also know how many neutrons and how many electrons we have. Okay, in a neutral element, okay, so for a neutral element, okay, this means that it has no charge. Okay, we'll talk about ions, and that'll be something that you will discuss later, but this means that the atom that we're discussing does not have a positive or a negative charge on it. Okay, so for a neutral element, the number of protons is equal to the number of electrons. Okay, so the atomic number, since now we know the atomic number is equal to the number of protons, so the atomic number is equal to the number of electrons in a neutral element. Okay, so earlier we just said that bromine had an atomic number of 35, which means it has 35 protons. It's a symbol for protons since they are positively charged. And it's going to have 35 electrons. This is the symbol for an electron since it's negatively charged. Okay, but what about neutrons? Okay, these are neutrons. This is where something called the mass number comes into play. The mass number is equal to the number of protons plus neutrons. This is a number that has to be given to you. It is always a whole number, and it does not come from the periodic table. Okay, so this has to be given to you, and we'll see why in a few minutes what a mass number is. And basically it accounts for all of the different isotopes of an element. Okay, but for now, let's just say that the mass number that was given to you for bromine is 80. Okay, so we're given a mass number of 80. Okay. We know that our number of protons is 35, but we do not know neutrons. Okay, so really if you're given any two of the three variables, you can solve for the other. But we also know that if we're given the number of protons, or we know the atomic number of an element, then we just go to the periodic table, and that's our number of protons. Okay, but here we are given the mass number, and we want to find the number of neutrons. So we'll do a simple mathematical operation. And so if we solve for the number of neutrons, so if you have your calculators, or you can do this in your head, you're going to get 45 neutrons. So if we subtract 35 from 80, we get 45. Okay, so let's do another example. If you were given the element sulfur, okay, so sulfur is our element, and we're told that it has a mass number of 32. Okay, so we would go first and find sulfur on the periodic table. All right, so we would go there. So everybody, if you've got your periodic table, pull that out, and you will see that sulfur has an atomic number of 16. So it has 16 protons. Okay, this also means it has 16 electrons. But now we want to know how many neutrons we have. So mass number is equal to protons plus neutrons. Okay, so we solve for neutrons, and we find that 32 minus 16 is equal to 16. So we would have 16 neutrons in the neutral sulfur atom that has a mass number of 32. Quickly, we are going to look at where we get mass numbers from. And how we get mass numbers is by adding up or averaging really all of the different isotopes of an element. Okay, so what's an isotope? Okay, these are atoms of the same element. So if they're the same element, they have to have the same number of protons. Okay, but they have different mass numbers. Okay, and since we know that mass number is equal to the number of protons plus neutrons, they're going to have a different number of neutrons. Okay, so it's the same element. The atoms are the same, but they have a different number of neutrons. Okay, so if we have a big quantity of magnesium, it doesn't just exist as one isotope. Okay, so how we write this actually, it's kind of opposite of what you'd think. When you look on the periodic table, you see that magnesium has its atomic number on the top of it. Okay, so if we look at magnesium on the periodic table, it has a 12 up above it. Okay, but how we actually write these chemical formulas here for isotopes is we have the element, okay, so E for element, here it's magnesium, and we actually put the atomic number, so here is our atomic number, and then the mass number as the superscript. Okay, so our 12 is here, and here we're showing that we have 3 different mass numbers. Okay, so these are 3 different isotopes. Okay, they have to be the same element. Okay, magnesium, magnesium, magnesium. They have the same, if they're the same element, they have to have the same number of protons, but they have a differing number of neutrons, okay, by 1 and then another neutron. Okay, carbon is another example. So most elements exist as isotopes. So there's 2, 3, 4, how many ever isotopes of the same element. So if we look at, we have carbon 12, carbon 13, carbon 14. Okay, so the number up top is the mass number. Okay, so this is the mass number. Okay, there it is there. There it is there. Okay, we don't have to be given the atomic number, because now we know that if we look at the periodic table and we find carbon, that we see that it has a 6 above it, which means it has an atomic number. So it has an atomic number of 6. So we can place this here if we would like. It has to be the same throughout because all of these are isotopes of carbon. Okay, and so if we have to have 6 protons, if we were going to fill in a table, okay, of the protons, neutrons, and electrons for each of the isotopes, we know we would have 6 in all of them because the number of protons can't change, or we change the element. Okay, we have a neutral element. We don't have an ion, a positive or negative charge. So number of protons is equal to number of electrons. So we would have 6 electrons in each. Okay, the only thing that would vary here would be the number of neutrons. So we know that the mass number is equal to protons plus neutrons. We know we have 6 protons. And in our first column here, we have 12 as our mass number. So if we do the math, 12 minus 6 would give us 6 neutrons. Okay, and if you want to stop and complete this yourself and then see what the answers are, you're welcome to do the second and third column. Okay, but C13, so we have 13 protons and neutrons with 6 protons, and 13 minus 6 would give us 7. Okay, so we're just showing what an isotope is. All right, the first isotope, we have equal numbers of protons, neutrons, and electrons. And then in C13, we have 1 extra neutron, which gives us 7 neutrons. Okay, carbon 14, 14 minus 6 gives us 8. So this isotope of carbon has 8 neutrons. So the definition of an isotope is atoms of the same element that have different numbers of neutrons.